And welcome everybody. My name is Professor Liz Bentley. I'm Chief Executive at the Royal Meteorological Society, and I'm delighted to welcome you all from, well, the far-flung places I can see appearing in the chat. So quite a few people from the UK, but I can see people from further afield as well. So welcome everybody to this virtual Royal Meteorological Society event that we're running jointly with the Royal Institute of Navigation and the RIN Special Interest Group. I'll introduce the speaker in a minute, but I have a few admin slides just to get through really before we can get on with tonight's presentation. So the first thing, a couple of slides really. The first thing to mention is the Weather Club, which is the Royal Meteorological Society's public outreach activity. It's a website. You can see the URL at the bottom of this slide. And I'd encourage you just to go and have a look and have a browse around, look at the content on the Weather Club website. There's a lot of free content, news and weather items, some science lessons on there, and some personal stories from people working in meteorology. So I'd encourage you to have a look at the Weather Club. The second slide focuses on the Royal Meteorological Society membership. So again, if you're not a member of the Royal Meteorological Society, I'd encourage you to consider joining. There's lots of benefits, a lot of them listed here on this slide. But it's an opportunity to meet like-minded people with a similar interest to yourself. So if we just move on to Demio, the system that we're using tonight for this virtual meeting, if you have any problems with the system, sometimes if there's any audio problems, what I'd encourage you to do is actually exit the whole meeting and then make sure you rejoin by cut and pasting the link to the meeting in one of the 4 browsers that you can see here on this slide. They're just the browsers that are more compatible with the system that we're using this evening. If you want to make the slides a little bit bigger, there's a couple of icons that you'll see at the top of the Demio screen. So the diagonal arrows will enlarge the screen, and you could close the chat. So this is the vertical line with the arrow pointing to the right. You can close the chat. So then the screen just looks larger on your screen at home. So you'll be able to kind of maybe get more out of the presentation as we go through this evening. But do keep the chat handy, and I would encourage you to ask questions as we go through the presentation, and we'll have plenty of time at the end of the talk to be able to answer as many questions as we can. So I'd encourage you to add questions as we go along, and I'll be fielding those to our speaker after his presentation. And just some information about some further virtual meetings that the Royal Meteorological Society is running over the next 3 weeks. We've got a meeting next Wednesday. Professor Tim Sparks is coming to talk to us about phenology, so looking at something called Nature's Calendar, and how we can use phenology to capture information about our climate and how our climate's changing. The week after that, we've got a meeting on air quality and the health impacts that's had, with a focus on 2 wildfire events. So one that took place on Saddleworth Moor in Yorkshire, and the second one, the wildfires that we're all familiar with that happened in Australia. And that's Ailish Graham, who is presenting on the 10th of December. And then on Wednesday, the 16th of December, so the week after that, we've got a series of speakers. So this is an afternoon event. And this looks at 100 years of meteorology at Imperial College in London. So it's this year, 2020, is their 100th anniversary of the meteorological department. So we take a look back at those 100 years, and there'll be speakers from people who've worked there in the past, but some current members of staff at Imperial College as well. So I'd encourage you to join. So without further ado, I'd like to introduce tonight's speaker and welcome Simon Rowell to the presentation. So Simon has been a yachting professional since 1997. He worked for Clipper Ventures, both as a round-the-world race skipper on the Winning Boat in 2002, and also an assistant race director in charge of the day-to-day operations and all the skipper and crew training that took place in the 2005 race. He's an RYA Ocean Yachtmaster examiner, and he spent 2 years as chief instructor at the UK Sailing Academy in Cowes. In 2009, he went back to university as a student, and he was studying meteorology at the University of Reading and finished his master's course in 2010 with a distinction. Since then, Simon has been a forecaster for the Clipper Around the World race and been doing that since 2011. He's worked with other clients ranging from ocean rowers to TV production companies. And since 2015, he's been the meteorologist for the British sailing team, forecasting for the 2016 Olympics and Paralympics, and hoping to go out to Tokyo next year for those events as well. So the presentation that Simon's giving today is entitled Forecasting for Dinghy Regattas, and I guess it takes a closer look at the subgrid scale below, behind the model to draw out more information for sailors from what you can get from weather forecasting information. So I'll hand over to Simon.
Very much, Liz, and hello everybody. Good evening. Thank you for joining in from lots of places around the world. This is really interesting. Now, thanks for that introduction. That's great. I guess really the object of tonight's talk is to try and see how we can look at getting a normal generic weather forecast and then taking it down to something which can help sailors and coaches actually make better decisions on the fly on the water. Excuse me. Now, the thing about small boat regattas is that they always take place on bodies of water, for example, large inland lakes or reservoirs or bays or just offshore along the coast. So there's always land involved. And as we know, once you take land out of the forecast, then life becomes a whole lot simpler. So if we did have this whole blue planet scenario, then the job of a meteorologist and as a forecaster in general will be a whole lot easier. But obviously, there's certain practical problems involved with that. So really, it's a case of trying to see how the land closely affects how the land that's close to the water affects the forecast. Right. So this is what I'm going to be going through in a little bit of the major sections of the talk. First of all, what's the forecast for? Why do we care? What does the customer want? How they use that forecast to set themselves up for the day. Then I'm going to talk about the way I personally go about getting a forecast and putting it into a form which is useful for the sailors and the coaches and anyone else on the team who uses it. Really importantly, monitoring that through the day to see how the progression goes, because I guess especially I always tell people that being an operational meteorologist is quite good, because you're never entirely correct, and it just depends on how wrong you are for the day. So monitoring your forecast through the day to see how it actually behaves is really important. And then of course the really vital thing about giving a forecast to sailors on a small scale is thinking subgrid, thinking how the particular features and how the weather systems will actually change through the day to affect the small detail of wind that they see on the water. And I also want to try and put this in perspective of the environments that these forecasts are used in. It's all very well talking about subgrid forecasts and high resolution this and all that, but the sailors are the ones who are going to be using this at the end of the day. And as we'll see, they have quite a busy job. So I can't load them up with technical stuff that they don't really care about. I need to load them up with stuff which is going to be of use to them that they can think about quickly. So anyway, that's the overall structure. And what's the forecast for? Why do we care? What do the sailors really need for it? Now, in my view, there's two main aims for a sailing forecast. First of all, to allow the boats and the equipment to be set up properly, because depending on the wind strength, for example, you might want to use different sails or different bits of different foils, different kit, and then to look to help the sailors themselves make their own choices for the clothing, the wetsuit thickness they're going to wear, that sort of thing, and also, of course, to make once they've got themselves set up optimally, to help them make the best decisions quickly in the heat of racing on the water. So, going through to the setup then, what we call the dinghy park shuffle. At any large regatta, there's maybe 1,000 plus sailers on several hundred boats. This photo was taken in the Hyères regatta. Here's a lovely French town on the south coast of France. This is one good thing about sailing meteorology, by the way. As before I got into sailing, I used to, my first degree was electrical engineering, and I used to throw things down oil wells in various parts of the world. I go to much nicer places now than I did when I was in the oil and gas business. Anyway, I digress. So on the south coast of France, you can see there's a lot of this is a very big international regatta. All the nation flags are on the harbour wall behind there, and every one of these boats, every one of the crews and the sailors involved with each of these boats will be choosing their equipment, getting the boat rigged up, maybe having their rigging set up slightly differently, different angle of mast rake, whatever it may be, for the conditions that you forecast during the day. So really what I need to give them is this is a whole broad brush thing now, the expected wind speed range, whether that's going to increase or decrease during the day, so that they can get their kit set up properly. And for their personal kit, sea and air temperatures, whether it's going to rain or not. And that's, I don't send this forecast out just to the sailors, it's all the support staff as well. Is it going to rain or not? Do you need to pack a waterproof, that sort of stuff. So this is fairly broad brush, very basic, but it does set the day up nicely. Right, so now for me, getting the forecast itself, this is, as with all things I've found in my life, tends to start with a cup of tea. I normally my forecast presentation to the team happens normally around about 8 o'clock in the morning. So I'm normally up quite early. And as soon as the sun comes up, I tend to either go out. I try and get down onto the water, ideally with a mug of tea in hand, and just have a look at what's going on, because that's looking out the window if you're doing a weather forecast is really useful. Whenever I do weather forecasts for, which I'm doing at the moment, for example, I'm at home in Cornwall, and the windsurfing European Championships are on at the moment in Villamora on the south coast of France. So every morning, the guys there send me photos of what's going on, just to allow me to, as much as I can, look out the window. So this particular photo here, this was in Palma, on the south coast of Mallorca, and this was taken just after dawn, March the 30th last year. This is at the Princess Sophia Regatta, which is the first big European regatta, and it's a huge one. It's an absolutely massive one. Excuse me. Teams all over the world come, places crawling with sailors for a good fortnight. It's great fun. So for me, this day, went out to the beach with a cup of tea and just had a look around. And there's things you notice immediately. There's an inversion going on here. You can see that it's hazy down at low level over land and out to sea. There's the small puffy clouds, full broken up clouds just above the. I get technical in the description. Sorry, I'm not very good at that. Just above the inversion, and though obviously this is a still, it's not a video, but there was a light offshore breeze just taking those clouds offshore above the inversion. There was absolutely no wind at surface then. It was all completely dead. This layer of sort of stagnant air just there. So that is a good thing to know, because the next thing I always do is I look at the big picture, and I always start off with a synoptic chart, generally the analysis and the 24-hour forecast. And this is part of the forecast that I present and send out to the team in the morning, because a proper sailing forecast, in my opinion, shouldn't just be a table with a list of times and what the wind speed and direction and what the weather conditions are. That's all a bit, that has nowhere near all the information that the sailor needs. The sailor needs to know, what type of weather is it? Is it going to be stable or is it going to be unstable? I'll come to that in a little while. What might change? What am I looking for? What weather features are going to be coming through? So the synoptic charts obviously tell us what the overall systems are driving, what systems are driving the weather. And today, as you can see fairly obviously, the big yellow dot is Palma, by the way. And these particular charts are from the Spanish forecasting agency, AEMET. I always try and use the local national agency, because generally I figure they have a reasonably good handle on their own weather, and most of the time that works really well. Depending on that, I normally default to the Met Office where I can get the information. Anyway, so this is a high pressure driven day, so it should be fairly stable, the overall atmosphere, and that inversion that we saw ties in nicely with that. So I'll then have a look at the satellite images. Now, this one, because sometimes I'll actually I'll zoom in more, but it depends what time of day, what type of day it is. this day, as we mentioned, it's a high pressure dominated day. So what I wanted to show the team here was the fact that over most of the central Med, there's hardly any cloud, which is typical of your high pressure. There's a bit more down to the southwest, but that shouldn't affect us today. I tend to use thermal infrared images, mostly because you can then get a pretty much direct idea of how high the cloud is. But visual images have a really useful role, especially around about dawn and the couple of hours after dawn, especially if you've got things like fronts or you've got clusters of cumulus clouds coming through, because they throw nice big shadows, which if you catch the image an hour or so after local dawn, shows up really well. So in that situation, what I'd probably do is zoom in more to illustrate to the sailors things like squall lines coming in or that sort of stuff. So now I used to use the Dundee University Satellite Archives every day. I was mortified when that had to shut down. And nowadays I get my satellite images from a commercial company called Squid, which is very good. They do geolocated images, which is very handy because you can overlay those onto nautical charts, onto navigational charts, which can be really useful at times. Anyway, so excuse me. This gives me the big picture, what's happening overall, and now I have to start getting it down to something which is more useful for the sailors. So this is taken from the sailing instruction. Every regatta has a list of sailing instructions, which is how the regatta is going to be run, and they always show the course areas. So this is just lifted directly from the event documentation. The two yellow dots there on the land, those are the two marinas that everyone's based out of, with a couple of miles in between. And you can see there's 8 specific course areas over the bay, and each one of those is 1.2 nautical miles across. So what would that be? That'd be about 1.4, 1.5 normal miles, and I can't do the conversion to kilometers. Anyway, so that's where all the racing is happening. Now, this particular regatta, the Princess Sophia Regatta, it's an annual event, normally at the end of March, beginning of April. It's huge, as I mentioned. There's 10 Olympic classes and others too. There's over 1,000 sailors on the water, and generally racing happens from about 1100 in the morning till 1800 in the evening. And for me to give a useful forecast here, I need to show how the wind and how the conditions are going to change across all of those courses. Because what's happening in the northwest corner of the bay is going to be very different to what happens in the northeast corner of the bay, because of the way the land changes around that. So this is what I have to go through next. So the next thing I normally look at is high resolution forecasts, and there's loads available these days, which is great. I tend to try and scrounge whatever I can off the internet and pay as little money as possible for it. But around Europe anyway, the normal models I try and look at are the ones I've shown up here. So if I can get hold of Met Office plots, I do that because I like Met Office forecast. I know it's not a high resolution one outside the UK, but I trust that model, and it works well for me. I use Icon EU from Germany. Meteo France's high definition Arome model I like a lot, and they overlap the boundaries of France quite a bit. So that's available for most of Europe. And of course the ECMWF model, which itself isn't high resolution, but there's several companies, one of which I use, called Predict Wind, which will do post-processing on that and get you a 1 kilometer resolution forecast from there. So I'll have a look at these, and on top of that, I'll use my own experience of a particular venue, and we're very good in the British sailing team at actually collating data, at noting down people's observations from various regattas wherever they've been. So we tend to try and I'll use all that to actually work out what's going to happen, basically what the effect of the land is, how that heats up during the day, will have on the local flow across the whole of the regatta area. And this is again part of the forecast that I put out now. So it's a fairly crude graphical forecast, but what I'm trying to show here is how the breeze is going to change across the bay during the day. So with your morning offshore wind before the actual sea breeze cell starts up, then round about midday the sea breeze cell should start to just push in through the bay. And normally in Palma, it pushes in from the southeast and comes around the bay there, and be filled in completely by about 1500, like that. I will fill that in more with I'll have other things on the forecast. I will have the famous table through hour by hour with wind speed and direction, and I'll put in information as well, talking about how excuse me, talking about how the stability and the steadiness will change. Now, for me, if I talk about a wind being steady, I talk about what I mean there is that the means are much the same. So you can have a steady wind, say, coming in from the southwest, and that'll come in at 225 true, and it'll stay there. But you can have it being steady but unstable around that. In my forecasting, well, the way the habit I've got into the team over the last few years is to differentiate steadiness, which is basically how the means are, and stability, which is how the wind is varying around that, because that has an effect on how you plan your tactics for the race. Anyway, so that's my forecast done, and it's really there's nothing terribly technical about this, I'm afraid. I start with the big picture, and then I work my way down, and then I spend a lot of time thinking about how the land is going to affect the wind through the day around the course, and with a bit of experience, that works out quite nicely normally. Then, of course, it comes to monitoring the whole forecast during the day. So no forecast ever survives contact with reality. We are fortunate in the British sailing team that we have a very good set of on-the-water wind instruments that will give us some real-time true wind direction and speed on each of the coach boats. So this was that particular day around about noon, and it's great because you can see the sea breeze coming in, and this is just a crude graphical interface, but if it's red, it's slightly stronger. If it's green, it's slightly lower. So you've got the last of the morning drainage is dribbling off there, and you've got your sea breeze coming in to the bay like that. So this is great. It's nice to be able to monitor it like that. Also, however, really important, as well as looking at the wind speed and direction, which is great, but the sailors can't look at that because they haven't got wind speed and wind direction on the actual boats themselves. And the most they'll have is a little digital compass and a telltale, either on the deck or at the top of the mast, depending on their preference. So they haven't got access to that. What they have access to, however, is their senses, what they can see and what they can feel. So they can look at how cloud formations change, and they can look at patches of more or less wind pressure on the water. They're extremely good at using other boats as wind instruments. So if another boat has to bear away 5 degrees because the wind's shifted, then they will pick that up from a long way away. They're extremely good at that. So what I try and give them as well as part of the forecast is a list of visual clues that will happen during the day. And on this particular day, to sea breeze day, started off in the morning, as I mentioned before, excuse me, with an inversion there, a fairly solid inversion, keeping the wind at surface really light, and an offshore breeze above that. So ideal conditions for a sea breeze to develop. And this is what happened at just after 10:30. Not hardly any wind on the surface. You can just see. Oh, I'm sorry, I'm moving my mouse around, which is no use to you whatsoever. But if you look at in the foreground of that image, you can see a couple of people on stand-up paddle boards, and there are a few sails in the distance, but there's no wind inshore at all. Maybe a couple of knots. That's all. But what we can see here is we can see little puffs of cumulus cloud, well, little puffs of scrappy bits of cloud, just developing over the land and still moving offshore like that, which means that it's still unstable with air rising up from underneath over the sea. Also, what you see here is that the inversion is nowhere near as strong, it's nowhere near as hazy as it was. So this is all good news if you're expecting a sea breeze to start. This is just an hour and a half later, 6 minutes past 12 that same day, and you can see, bang, the breeze is in. If you look in the bottom left-hand corner of the photo, you can see a bunch of boats all nicely heeled over. and there's a developing line of cumulus clouds just inshore on the coast, which is exactly what you'd expect for a sea breeze cell to actually bring. Also, and this is really important if you're trying to work out whether your wind is a gradient-driven wind or a sea breeze, is if you look at the clouds at the same level as the cumulus clouds there's no small scraps of cloud going out to sea. The small scraps which are there die out, and that's typical of a sea breeze, because if you think of what a sea breeze is, it's your air going out to sea, and then cooling down above the slightly cooler water, and then falling down like that. And if you have air subsiding like that, you can't have clouds, because clouds are little droplets of water held up by air going upwards. I told you this is going to be technical, sorry. So this is your sea breeze developing nicely now. Then, of course, later on, halfway through the afternoon, excuse me, the cumulus clouds are now at their biggest. Sea breeze is at its strongest, coming in. And what will happen during the afternoon from now is those cumulus clouds are a pretty good measure of the strength and how the longevity of the actual sea breeze cell itself. So when those clouds, which are driven by the sea breeze coming in and bringing moisture in, when they start to decrease in size, then you know your sea breeze cell is also going to be weakening and becoming patchier and shiftier, and that has an effect on the tactics that you use on the race course. So the sailors all know this. What almost every single sailor will tell you is that they're no good at weather. But what every single sailor doesn't realise is that they've all been rained on a lot over the years, and they're a lot better at weather than they think they are. And they know this stuff just by looking at it. And this is a really important part of my job, which is not only to give as good a forecast as I can, as accurate as a forecast as I can, but also to tell them what to advise them what to look for and what they should see as it goes on, so that they understand things better and can make quicker decisions without really having to think about it, with it just almost like a background task. So this now I have used this slide often in talks before, so if you've seen this before, I apologize, but this illustrates to me why you need to both as a sailor and a forecaster to think about the land around your sailing area. This is Guanabara Bay, Rio de Janeiro, basically. This is where the 2016 Olympics were held, and there was a 1 kilometer commercial model who I used every day because it was a really good model, and they had the timings. The timings of things were really good from there. And I was curious, and I asked them if they'd share their landmass, their model of the topography with me, and they did very kindly. So blue is obviously water, green is low land, and the brown stuff is higher land. So you can see that the main bay that Rio sits around is surrounded by this 40-kilometer long box of mountains, or parallelogram of mountains, which is exactly what happens there. If we zoom in a bit more, this is the area specifically where all the Olympic sailing happened, and the yellow circle I've got there is where the medal race course was, which is basically the medal race, as I'll talk a little bit about later, is the race that all the Olympic medals are decided on. So it's the last race of the regatta for each of the 10 Olympic classes. So it's a really important race course. If you look at the topography around here, down to the west-southwest of that, from that yellow medal race, but you can see a ridge of higher brown grounds, and that's those hills there. That's where the Christ Redeemer statue is, for example. Now, most of the wind in Rio came from either anywhere from about southeast to southwest, a mixture of onshore gradient-driven wind and sea breeze cells. So looking at this, you think, oh, brilliant, that all looks quite good. The medal race course, yes, there's land all around it, but there's nothing really big getting in the way of it and the wind. Well, nothing that the forecast model can look at anyway. But there's one slight thing in the way here, and that is that sugarloaf. Now I've marked that in red, where it is actually physically on the landmass there on the left-hand side of the screen, and on the right there's Sugarloaf itself, and this is the single most important lump of rock around that harbour for this particular regatta. And it was hugely important to understand how the wind moved around it, how it flicked around it. What we found was that downwind of it, for example, you could get seemingly random changes in wind direction, about 20 or 30 degrees each way. Whereas if you were sailing outside the harbour, you didn't get those at all. It was maybe only 5 or 10 degrees. And what we worked out was that if your wind just changed a little bit that way, then it would go around one side of the rock. And if it went a little bit that way, it would go around the other side of the rock. And this would change whether it was a stable sea breeze or a more unstable gradient-driven wind, which could go slightly over as well as around. So this is a great example. This is the best example I've seen of why you should always think about what's actually going on with the land that the wind has to flow over and around, especially when you're using high-resolution models close to land or around land, because this is not a criticism of the model. As I said, I use this every day, and I really rated it for the timing of things changing, of wind moving and all that. But it's just the way life is when you're trying to model anything with a computer model, with a numerical model. If something is smaller than your grid size, then it doesn't exist. So that's a really important thing to bear in mind when you are doing forecasts for small scale stuff. Okay, so let's have a look at decision making on the water now. Excuse me. Now this is John Gimson and Anna Burnett, who are the current world champions in the NACRA 17 foiling catamaran, which is what you see here. They won their world championships in Geelong in Southeast Australia at the beginning of the year, before all this, before everything went completely Pete Tong this year. And I'm just using what I want to show is some shots of the race that they won their gold medal in, just to try and illustrate the small margins that are important, or in play when you're sailing boats which are fast and which have a small race course. So obviously this is a foiling catamaran. As with any foiling boat, if it's out the water, if it's actually flying on the foils, then it's going fast. As soon as the hulls get back in the water, as soon as it goes into displacement mode, then the foils are basically just drag. So most of a large part of the sailors' thought process and physical manoeuvring is to do with keeping those hulls flying. It's really important. So there's not really a lot of time for discussion and debate. So let's have a look at this now. So this was the medal race course. Now the way that most dinghy regattas run, and this is the Olympic format for this year, for this cycle at least anyway, is that there will be a qualifying series of up to a dozen races, which happens over normally a 5-day period. Now, the way these things are scored is that on those, say, dozen races, you basically add up your positions, and you're allowed 1 or 2 discards. So in other words, you can bin your 2 worst races if you had a complete, if it all just went horribly wrong on one particular day. And basically, the person with the lowest score wins. That's the way it works. What happens in the Olympic format is that at the end of the qualifying series of, say, a dozen races, the top 10 boats, so the boats with the 10 lowest scores, will go to a separate medal race, which is a double points race. Excuse me. And the medal race it's normally much shorter, so it only lasts about 20 minutes, and it's 2 laps of a windward-leeward course. So looking at this, the actual course itself, there's this. I'm using my mouse again. That's no good. In the top center, you can see there's this little group of 4 flags. The top pair of flags, that's the actual start line, and the bottom pair of flags there, that's the gate that they have to go through when they come back down the course going downwind. If you go all the way to the bottom of the slide, you'll see 1 flag all by itself with a little wind arrow next to it. That's the windward mark. So the actual wind in this case, in this situation, if you look at the top left-hand corner of the slide, you can see that it's coming from a little bit west of south, probably about 190, give or take. And when this snapshot was taken, it was at about 16 knots. So fairly punchy. 16 to 20 knots when you're on a flying, when you're on a foiling catamaran, can be really quite breezy, because of course if you're sailing across that at say 17, 18, 19, 20 knots, then the actual apparent wind speed is considerable. So it's all pretty hectic. It's all pretty hectic at this point. The actual scale of the course, I've got the 1,000 meter scale up at the top there, so you can see that the course itself is about maybe it's under 2 kilometers long, and they basically do 2 laps of it. So that's the way this has to work. Excuse me. So if we so this was at the start. Now, just let's have a look at the start. What I've done here, I've exaggerated. There's any little red arrows you see, those are weather stations which are recorded by the organisers. This tracking is done it's done by the firm SAP, as you can see from the top left hand corner there, and basically each boat has a GPS tracker on it, which allows this sort of analysis to be done afterwards. And you can download this for loads of regattas if you go to the SAP sailing site. So looking at this, I've just exaggerated the wind arrows because they're not that easy to see. So you can see that the wind isn't constant across the course. The forecast for this particular day was a strong gradient driven south-southwesterly, which we have. It's not quite that far right, but it's given there. Backing left in the early afternoon, which it seems to have done. This was at about 3 o'clock in the afternoon. It was a very thundery, squally day in the morning, but we still had squally rain showers coming through all day here. And what you can't see, but below the screen, if I extended the map out, there's this is in the middle of a large bay, so the wind actually comes over a fair amount of land itself, which is quite hot. This was, don't forget, midsummer down in southeast Australia, so this particular day was relatively cool. It was a mere 25 Celsius, I think. I was in my shed in Cornwall forecasting from there, distinctly less than 25 Celsius. But anyway, so it's but the breeze was forecast to be fairly steady in direction, so the mean was fairly steady, but very unstable, both from the heating of the land underneath it, and also the fact you've got lots of squall clouds coming through as well. So this means that what that means to a sailor is that, well, this is what I think it means to a sailor, is that if you know the mean is going to be fairly steady, then if it bangs right by 10 degrees, then it'll come back fairly shortly afterwards. If it bangs left by 10 degrees, then it'll come back fairly shortly afterwards. It won't go there and stay, which is really important when you're thinking of tactics. So that's the forecast, and also I always put out a forecast confidence, whether I think the forecast is reliable or not, even by my standards. So the confidence rating I put for this day was good, because I was happy that it was a good synoptic setup. It was well understood, and the forecast would be okay. So I'm going to look at 2 particular boats to explain what's going on here. John and Anna are on the red boat there. And then I'm also going to look at Santi Lang and Cecilia Carranza, who are the current Olympic gold medalists from Argentina. And you can see just after the start here, both of these boats are in pretty much the same patch of water. They're going up the middle of the course. And we'll see how that changes. So this now is halfway up the first beat. So they're halfway from the start to the top turning mark. And you see there's already a bit of a gap between the red British boat and the purple Argentinian boat there, and that really comes down to excuse me. Also, another thing to note is that the wind is slightly to the right as you're looking upwind there, compared to the wind in the middle of the course and the wind on that side of the course. So it looks as if the wind on that side of the course has gone right just a few degrees. So what's happened here, if we zoom in a bit, is if we look at John and Anna's tack, that's pretty straight, and then they tack and head off there. Whereas if we look at Santi and Karina's track there, it's fairly straight, and then they get headed. In other words, they get the wind goes a bit right, not much, but a bit, and they get pushed away from their initial heading. So they actually lose a little bit of ground, and it's these small differences that can make a huge difference. Now, these are not bad sailors. They are the current Olympic gold medalists. So maybe something else. Maybe there was another boat in the way that had right of way, and they couldn't tack, whatever it was. But anyway, on this particular case, that's what made the difference just for that small gain there. Now, excuse me, this is now the next beat coming, because this is the second lap coming upwind, and there's a couple of things going on here. You can see that John and Anna have now a big lead on the Argentinian team there. Also, it's difficult to see if your screen's small, but the British boat is going at 10.7 knots. The Argentinian boat is 7.9. So there's a couple of things that I'm looking at here. First of all, there seems to be more wind now on this part of the course here. So potentially the sailors are looking for things to see a darker patch of water over there. There's more wind. If I go sailing there, I'll go faster. And I suspect they also had a couple of better tacks on the way as well. So that's really just illustrates a little bit of the decision making they've got to make. They've got to think, can I check the wind direction changes? Can I see them? And am I looking for pressure patches enough? Can I see patches of darker water on there? And if I can see those patches of darker water, which has more wind to ruffle it up, is it worthwhile going for them? Are they going to hang around for long enough, or am I just going to sail over there and find no difference at all? So, as my meteorologist, what I try and do is try and give them some advice on this, and for that I look at the tephogram, the SQT diagram, the balloon sounding. Now, the great thing is with numerical weather modeling is that you can get forecast balloon soundings, which is really handy. So this is a balloon sounding for forecast data, and for this I used the GFS model and a software called Zygram, which is very useful for this sort of thing. Free to download. I always like that. Free to download. And if I zoom in a little bit more on the bottom part of the atmosphere, on the actual boundary layer here, there's a couple of things you can see. First of all, the red temperature line and the blue dash dew point line, they're overlaying for the bottom kilometre and a half or so of the atmosphere, which obviously means you've got thick cloud, which ties in with the forecast for squally, thundery, for thunder to start with a generally squally, cloudy day. And that means that if you've got a squally, cloudy day, then those squall clouds themselves will actually give their own little gusts and puffs coming off the bottom of it. Also, looking over here at the wind barbs going up the side there, that boundary layer is quite deep, right? And if you think back to Lewis Richardson's wonderful little bit of doggerel back from 1922, big walls have little walls which feed on their velocity, and little walls have lesser walls, and so on to viscosity. My little brain sort of thinks of this. You've got a nice deep boundary layer, then you can have big circulations there. So what I tend to find is that when you have a nice deep boundary layer with a deep surface wind going, it's unstable as well, mixing down as it goes, then those pressure patches can actually be quite long lasting, as you have the faster parcel of air just circulated down to surface, and it takes a little while longer to actually dissipate than if you have a short, shallow boundary layer. So anyway, that's what I try and tell them about, and that allows them to actually make decisions on whether they can go to a pressure patch or not. Because if it's long lasting, it's worthwhile going. If it's just going to be short, then there's no point unless you happen to be there. So I mentioned squalls. This is something to just have a quick look at with the effect of that on a sailing boat. So what I'm looking at this from above. The blue arrow is the surface wind as it would be without a cloud there. The red arrows are the downdrafts which come off the cloud and go out in all directions like that. So the wind that we actually get sailing around a cloud is a combination of the two. And if we look at the top of the diagram, which is if you were upwind of the cloud, then basically the wind, the normal wind at the surface as it is on the big blue arrow, and the gust that you get from the downdraft from the cloud tends to counteract that. So you tend not to have that much of a direction change, but you do get your wind easing down, so it's not as strong. If you're downwind of the cloud, so at the bottom of the diagram here, basically your downdraft adds on to the normal wind there. and you end up with a stronger breeze, which is unlikely to change direction much. So again, if you've got a nice lightweight expensive sail up, you have to make a decision as to, and one of these things is coming towards you, you have to make a decision as to whether to take it down, change it, or just hang on and hope for the best. That normally doesn't work. Excuse me, I've got a story about that, but I haven't got enough time tonight, sadly. Anyway, it's what happens on the side of the clouds, which is interesting, because basically what happens is that the wind will tend to try and push you away from the base of the cloud, which can be quite handy if you want to go a little bit further right or a little bit further left. So what that means is if you have a cloud coming down your coming down your starboard side, then the wind would tend to push you away to port like that. And ditto, if it was coming down your port side, the wind would tend to push you away to starboard like that. So how does this help people? Well, if you're going upwind, let's look at these two boats. The boat on the left, the cloud is either going to go over or behind. The boat on the right, the cloud is going to go in front of you. So as this approaches, the boat that the clouds, if we look at the boat on the left to start with, the wind will increase as the cloud approaches, but you're going upwind anyway, so you won't have anything silly like spinnakers up, and basically you just have to hang in there, take the gusts. But what will happen is that you'll actually get lifted. In other words, the wind pushing out from the cloud will actually help you to go further upwind, which will be better. On the other side, on the boat on the right there, as you approach the cloud, you're going to get headed. You're going to be pushed away from the normal wind direction, but you can tack and take the advantage on the opposite tack going along there. And then, of course, as the cloud goes past, then that's you go back to normal. This is obviously very idealized, but it does really work. And if we look at how the wind will change if you're going downwind, then again, the boat on the left, the cloud is coming behind you. The boat on the right, the cloud is actually going to go in front of you like that. Now, in this case, the boat on the right is actually helped with this, because basically they're going to be pushed away from the cloud. In other words, they're going to be pushed more downwind, so they can get further downwind faster. Whereas the boat on the left here, again, they're forced to come up. They're headed slightly, so they will actually have to make a decision to drive across or just suck it up and take the loss, and until the cloud goes past and go back to normal again. So I've just shown one particular cloud here, but this does work quite nicely. If you have a long cloud which is parallel to the wind, then you can basically get a bit of a lift going down one side of it, which is really handy if you want to be a little bit further left and it happens to be on the right side of you. So these things, this sort of thing, is something which not just me as the meteorologist, but all the technical support team, we try and the ideal way to actually sort of train or to impart meteorological knowledge, I think anyway, is put and training camps are great for this. You put a detailed forecast out and explain it, stand up in front of people, normally at breakfast because they're concentrating then, and you tell them what's going to happen. Then they go out and they sail in it, and you come back and you analyze it afterwards, which can be a little bit tedious. And if the guys have had a really hard day on the water, you can see heads nodding. But you've got to try. If you're trying to make it the short, sharp thing, then basically what they're doing is they're thinking about the forecast in the morning, then going out and sailing in it, and thinking about what happened afterwards, and that normally works really, really well. We're nearly there now. What I'd like to do is just is put this in a little bit of context to show you quite what happens on the water, and what I've got is I've got a little video to play here. Okay, so that particular video, right, just to explain a bit about the boat. Here we go. That was Dylan Fletcher Scott, who's the current UK international moth champion, and he's one of our Olympic sailors. He's the helm for the two-person 49er skiff. He was also excuse me, and he was also in the team for the 2016 Olympics. Now, the Moth is another foiling boat. It's not an Olympic class, but it's really up there with modern day dinghy sailing. It flies on two foils, one at the front and one at the back, which is also the rudder. The control systems are quite technical. You've got this wand. There's a wand at the front that you can see for touching the surface. So basically, the angle of that wand controls the angle of the trim tab on the bottom of the forward foil. At the back on the rudder, I don't know if you noticed there, it was all quite frenetic, but occasionally Dylan was actually twisting the tiller extension, and that angle controls the angle of the foil at the back of the boat as well. These are really fast boats. You saw how quickly he was going there. There was only I looked at the weather, that was in Weymouth, or Portland Harbour actually, and there was potentially 10 knots of breeze there. He was belting along like a belting along thing. Things that he was looking at, he was thinking about as he was sailing up there, the way that the southwesterly wind blows around Portland Bill. He was trying to, because on a relatively light wind day like that, the wind shadow underneath it is huge. And you can see how quickly things were going as he was tacking. So the point of showing all that was that they haven't got time to think about isobars. Right? They can't think about, Simon said that there's going to be, something happening over there, and watch that. Just, they haven't got time for that. So what the whole idea of giving them a usable forecast is to help them make split-second decisions better. And if they do that, because they're already really good technical sailors, if they can, as well as that, get a real handle on what's happening around the racecourse, then that allows them to make better decisions and win more medals, basically. And that's it for me. Thank you very much for letting me speak. It's, as you can see, I'm not the world's most technical meteorologist, but I can't overemphasize how much looking out the window, how much looking out the boat and thinking about what's happening around the water can affect your forecast and basically make you sail faster. So questions, please.
Great, thanks, Simon. So big round of applause for Simon. Thank you. So yeah, we're moving into the Q&A session. We've got about 10 minutes left. I've got quite a few questions actually in the chat, so we'll try and get through as many of these as we can. If you've any questions, please keep typing them in the chat, and we'll just see how many we can get through. Very quickly before we get to that, there's a poll running as well. I know half of you have roughly filled that in, but if you go next to the chat, there's a poll section just to get an understanding of the background of people on this attending this event. Okay, so first question comes from Andrew, and Andrew's asked, how long does it take you to pull together a forecast like the ones that you've presented today?
About 2.5 hours. I normally goes off at 4:45, and I'm normally standing up there. I've normally emailed and WhatsApp the forecast out at about 7:45, and I'm standing up in front of people talking to them at about 8.
Great. So there's a few questions actually relating to where you source some of this data. And so there's one from Clive asking, where's the best place to access soundings for a UK regatta? There's one from Tom who's asking about how you access the GFS SQT plot. How do you access things online? I guess generally, are there kind of well-known sources of where you can get hold of data that you've shown today? Are there kind of portals out there? Are the people that you follow that have all of these things kind of together to point to the thing, or is it just something you've built up over time?
A bit of both, really. Yeah. For soundings all over the world, actually, not just here. The University of Wyoming, bizarrely enough, is excellent. They have a great database. So have a rummage around the University of Wyoming. As far as forecast soundings go, there's a software which I think I mentioned called Zygrib, XYGrib, which is very useful for that. You can download various models and build up soundings from there. If just word of warning, if you are doing that at sea through a satellite link, don't do that at sea through a satellite link because the files are huge.
Brilliant, perfect, thank you. And any recommended sites to go to generally, or people to follow that that have collated places, sources of places to go to? Who would you recommend?
A great place to have a rummage around is if you do a search for Frank Singleton.
Yes.
Frank Singleton's site has a bunch of stuff on it. It really does.
Brilliant, perfect. So Danny noticed when you were doing the example in Palmer Bay that you've got an airport close by. Do you actually use any of the aerodrome forecasts in any of the any places you've been to? Do you access the data available from local information like that?
I certainly access the weather stations they got there. Absolutely, that's really important. The actual aviation forecasts that get put out locally, they are quite useful, especially for working out what things like gust speed is going to be. Because I always find that if you get the forecast for about 700, 800 meters up, so normally around about 925 hectopascals, the wind speed there is a pretty good idea of what the gust speed is going to be at surface. However, the actual aviation forecasts are often quite tricky to actually find. So what I do is I'll have a look at their observation stations, and then I will probably just use I'll just download three-dimensional data and have a look at what's happening above the surface that way, because that's basically where they'll get their forecasts from. In Rio, I did actually have quite a fun couple of days wandering around the airport buildings with a local guy there who was really helpful, and we ended up talking to a bunch of meteorologists there, which is very handy. But that was a bit of a one-off.
I guess you get an opportunity then to get the local knowledge if you can speak to kind of meteorologists who've worked there for a number of years, whether it's at the airport or even other localities. But getting that local knowledge is key, isn't it?
Yeah, very much so. Absolutely. In Japan, for example, in the build-up to Tokyo, the Japanese sailing team has been extremely good at disseminating on the water wind readings to all the teams, not just us. Where we're based, there's a couple of sailing clubs there, but with a bunch of very nice local sailors. And for the great thing about sailors, they like drinking beer, and if you give them a couple of beers, they'll tell you pretty much everything. It's wonderful.
Perfect advice, great. Okay, so we've got a question from Rich, who's a Royal Navy forecaster and RS Aero UK class chairman. So how do you communicate your forecast to larger groups of sailors and manage their expectations? So for example here, if there was a postponement due to light winds in a summer national camp, so how would you communicate that?
It does vary from regatta to regatta. Generally, normally I'm forecasting for the British sailing team, so we have a relatively small group of people. But however, I have done regatta support for example, the RWA when they're doing like the youth nationals at Weymouth, that sort of thing. So things like postponements, it's still quite old school. Bunch of flags go up. So the sailors and the coaches and all the teams there, they know to watch the flags during the day. In my forecast, what I will do, I'll do. This is what I think is going to happen. But just in case, especially when you've got firmly driven days like sea breeze days, for example, and then a bit on the edge as to whether the sea breeze will start or not, I'll always put a what if. If what I reckon didn't happen, then this is probably the most likely thing. And normally it's just a timing change, but sometimes it can be completely different. So again, I try and put that out to the sailors right at the very beginning of the day. And then I can keep in touch with them via WhatsApp groups, over the VHF, and then again, if I'm working for the regatta organisers as opposed to a sailing team, through flags.
Great, perfect. So I've got two more questions. See if we can get them both in before we close. So I've got a question from Mike. So he recalls there used to be a common view amongst UK yachtsmen, even at Olympic level, that wind speed and direction were correlated. So there was a so-called veer in gusts and back in lulls. Have you seen this?
No, that is not true. Almost always that is not true. And the reason that is the case is that if you look at how the wind works, going up away from the surface. If you're at sea and you look just dead ahead with both ears as cold, so you're looking directly into the wind, then in the northern hemisphere anyway, you'll look up and you'll see at sea the clouds will be coming from about 15 degrees to the right of you because of the surface friction changing as you go up. or decreasing as you go up. So in theory, the stronger wind up there that gets circulated down as your gusts should, in theory, be coming from the right. However, that the way the circulation happens in boundary layers is a whole lot more chaotic than that. And I've looked at vertical lidar soundings, for example. We've done things by we've stuck wind instruments up on long poles, all this good stuff. And almost always, by the time it gets down to surface, the wind is equally distributed left or right of the mean. In the last few years, I've only seen one example where that didn't happen. That was at Miami, at the Miami Sailing World Cup this last January, where there was a huge wind shear really low down. The boundary layer was only about 500 meters deep, and above there was about a 90-degree shift in wind direction. And that's the only time that in the last few years that I've found that in that case, yes, the gusts were coming from the right. But that was you can see that in the sounding. Can't quite remember what was going on, but it was really exaggerated. But 99% of the time, no, your gust direction will be distributed evenly around the surface wind.
Great, perfect, thank you. And final question, this is from Thomas. So given the near-shore location of regattas, how much consideration do you give to things like changes in fetch length, potential impacts of sea state in combination with the wind forecast?
Yeah, good question, and the answer is quite a bit, especially if the wind is changing from being, say, just about parallel to the coast to being onshore, and especially if there's say a rocky shore or a big harbour wall, because you get a lot of bounce back off that sort of thing. You can go out to sea quite a long way. So yeah, fetch is really important, and especially if you have venues which are open to a large ocean basin. Sometimes you can have a swell coming in that's generated by a system hundreds or even thousands of miles away, which is completely at odds with the local wind direction, which makes life really exciting.
Great. Okay, well, I think that's all we've got time for questions. So can you join me again in thanking Simon for an excellent presentation this evening? Thank you. Great. I think we have a few questions left, actually, Simon. What we might try and do is capture those questions, and if you can take a few minutes maybe just to jot some answers when we send out the email to point to where the presentation is online, we maybe can answer a few more questions if we've got time. So thank you again, Simon. So yeah, the slide here tells you about the presentation. It will be going up on the Royal Met Society's website hopefully tomorrow, so get an opportunity to watch any bits over again that you wish to. So a big thank you for everybody who's taken part. Final encouragement for those who haven't filled in the polls, please do so. It just helps us to understand the demographics of the people attending these meetings. And yeah, so another reminder of 3 meetings that we've got coming up over the next 3 weeks. So feel free to register for any of these. They're all free to attend, and should make some interesting and varied talks, as you can see from the 3 different topics that we've got coming up in the next 3 weeks. So it just leaves me really to thank Simon again for a really fascinating talk, a really interesting evening, and thank you all for attending. So bye for now.